What temperature must you raise a copper wire? Temperature coefficient of resistance of 3.9 times 10 to the minus 3 per degree Celsius, originally at 20.0 degrees Celsius, to double its resistance, neglecting any change in dimensions. Alright, given the temperature coefficient of resistance, alpha, that's equal to 3.9 times 10 to the power of negative 3 per degree Celsius. And the original temperature is 20.0 degrees Celsius. And at this temperature, the resistance is R0. The resistance after the temperature changes to T, the resistance final is equal to R0. Because it says double its resistance at 20 degrees Celsius. And what we are asked to find, what this temperature is, what the temperature is after the resistance becomes twice the original resistance. So how is changing the temperature affects resistance? And we know that R is equal to R0 into 1 plus the temperature coefficient of resistance alpha into the change in temperature T, final temperature, minus the original or initial temperature, where resistance is R0, is a T0. So now we can substitute R by 2R0, because it says to double it. That's equal to R0 into 1 plus the temperature coefficient of resistance alpha into T minus T0. Now we can divide both sides by R0, and that yields 2 equals 1 plus alpha into T minus T0. We can subtract 1 from both sides, and that yields 1 equals alpha T minus T0. Divide both sides by the temperature coefficient of resistance alpha, and that yields 1 over alpha equals to T minus T0. Rearrange the equation for T. T will be equal to T0 plus 1 over alpha. Plug in the numbers. So now the original temperature is 20 degrees Celsius. And 1 over alpha, which is given to be 3.9 times 10 to the minus 3 per degree Celsius. So 1 over 1 degree Celsius is degree Celsius, so the two terms have the degree Celsius unit, and that will be 8. That's 20.0 plus 1 over 3.9 times 10 to the minus 3 yields 276 degrees Celsius.